Assalamu alaikum students, your instructor Abdul Rafi here. So this is a new playlist that we are going to start, particularly on permutations and combinations, the chapter of A-level mathematics 9709, paper 5, that is statistics 1 S1 9709, the code of the paper. A lot of lectures will be there, different types of questions we'll be solving. So let's get started with one of our 2022 topical past papers. As the heading itself says, that these are 2022 topical past papers. This is question number 1 of paper 5 and variant 1 of summer, that is May-June 2022. Your instructor Abdul Rafi at your service. So here we go. Let's start. Question number 1A is on permutations, combinations. Find the number of different arrangements of the 8 letters in the word deceived in which all 3 E's are together and the 2 D's are together for 2 marks. Okay, so this is basically a lot of repetition question that comes with different words. Okay, you will face alligator, needless, evergreen, crocodile. A lot of words in recent past papers are coming and we are going to solve all of these words. Okay, so what are the tricks, what are the steps that you should follow carefully. Okay, after 5-6 videos you'll be able to solve all these questions clearly. Okay, so the first thing is always write the letters. Okay, on one side of the page, let's say the left hand side, you write it. So write all the words. So DEC, E is coming twice, and then I, and then V, and then E is coming another time, and D is coming another time. So 2 times D is coming, repetition of D's are 2 times, and repetition of E's are 3 times. Okay, and this is how you get all the 8 letters: 2, 3, 5, 6, 7, 8. So 8 letters are there. Okay, so first thing, you have done this. Now what is the requirement of the examiner? The requirement of the question is that the 3 E's are together and the 2 D's are together. So whenever you have a together question, when the examiner needs them together, so you do it like this way, students. Okay, you write them, all of them together, E, E and E, you write them together and make them in one box. Okay, similarly you write the 2 D's together, okay, and you make them in one box, and you write C together, C, I and V. Okay, and these can be written in 3 different boxes. Okay, students, so here we go, 3 boxes for C, I, V, and 3 E's together, 2 D's together. Okay, so students need to understand why I have done in boxes. I'm going to explain the reason as well. So if you see, these are 5, 1, 2, 3, 4, 5. So you are going to use 5 factorial in the numerator. Okay, you are going to use 5 factorial in the numerator. Now what does this 5 factorial means? And I'm going to explain this now, that what does this 5 factorial mean. So 5 factorial means that E's can come there. You can make it like this: C, V, 3 E's together in the next place, then you can write 2 D's together, and then you can write I in the next case. Okay, so you can change anything between them. Okay, you can change, there are 5 factorial, which means they can change their places in 5 factorial ways possible. Whatever the answer is for 5 factorial, that is 5 into 4 into 3 into 2. Next, you need to understand the concept as well, students. If this is 5 factorial, you need to understand that for the 3 E's, they can change their places inside. Okay, so E1, E2, E3, they can change their places inside. So that is why 3 factorial for them, and that is why 2 factorial for the 2 D's as well, because they can change their places inside. Okay, students, hope everyone is getting the first part, that 5 factorial is for them, that you can start, you can, because this is I have made. Okay, anyone can made V first, C second, I third one, then E's. Okay, and then the 2 D's. Okay, so students can, a lot of possible ways are there, a lot of arrangements are possible. Okay, because we are talking about arrangements, that is permutations. So hope students get this. That's why 5 factorial for them, and 3 factorial is basically, let me highlight as well, the 3 factorial are for this, that they can change their places inside in 3 factorial ways, and then the 2 D's, they can change their places in the 2 factorial ways as well. Okay, and in the denominator we are going to divide by 3 factorial into 2 factorial, and the reason is repetition because the words are being repeated. So that's why we have to do the repetition thing here. So they will have to be cancelled out. So eventually students, your answer comes out as only 5 factorial because these will cancel out. So your answer is 5 factorial, which is you can do in the calculator is 5 into 4 into 3 into 2 into 1. That is basically 120. Okay, so the first part A answer is 120 ways is possible for the word deceived to be arranged in the with 3 E's all together and 2 D's are together. That is the number of arrangements, different arrangements possible for the word deceived. Okay, any questions can be asked in the comment section. Hope everyone understands that how these type of questions, this part A is done. Moving forward, we have part B as well, and I'm going to explain that as well. So follow carefully with the trick and tips that you can use in this. Okay, it's just a practice paper. Okay, make sure as many questions as you will practice on permutation combination of the words, you will get better at it. Okay, so here we go. Find the number of different arrangements. Again, we have to arrange them, the number of different arrangements of the 8 letters in the word deceived in which the 3 E's are not all together. So you have already written the words here, so don't have to worry about it, don't have to write it again. You can take help from here again. This, if you write in this way, that makes it very easy to understand which repetition is there. So students needs to understand that this time very important statement is this one, in which 3 E's are not all together. So understand 3 E's are not all together means that you don't need this requirement. Okay, 3 E's cannot be together, that you need. Okay, so 3 E's cannot be together, that is your requirement. So what does this indicate? Your English should be good as well, so you need to remember and understand the question very carefully, that this means that 2 E's are possible. Okay, 2 E's can come and a lot of other arrangements are possible as well. So that is why we here will take the approach of the minus thing. From the total arrangements, you subtract what is not your requirement. Okay, just like we do in probability, 1 minus the opposite requirement, you get your required question requirement, right? So this is also we'll find out. So let me start and let me explain you how we'll find out this one. So it will be total arrangements without restriction. Okay, total possible arrangements without any restrictions. Okay, this is basically called a restriction, that is 3 E's and 2 D's together. So total arrangements without restriction, that is what you're going to first find out. Total arrangements without any restriction, that will be total number of possible different arrangements. Okay, so what will be total number of ways of the arrangements without any restriction? It will be, students, 8 factorial, because you have 8 letters, right? Because you have 8 letters, so this will be 8 factorial, sir, and that will be divided by 3 factorial for the 3 E's and 2 factorial for the 2 D's. Okay, so this is a normal 1 mark question as well. So this is 1 mark. Okay, this will form out of 4 marks, you will get 1 mark for this. So here we go. It will be 8 factorial divided by 3 factorial into 2 factorial. Make sure you do it in calculator, and I'm getting this as 3,360 ways. Hope the value is correct as well. You can check with the calculator. 3,360 ways. Students need to understand this answer. This answer basically indicates without any restrictions, without anything that 3 E's are together, 2 D's are together or not together, everything separate. Okay, 2 E's are together and no D's together. You have to make a difference between these. So this is without any restriction. Okay, it's the original answer. This is the total number of ways that are possible in the word deceived. Okay, that is 3,360 ways. Okay, students, hope everyone gets this. And now from this, you are going to find out the other thing, that is if the 3 E's are together, total arrangements if 3's are together. Okay, so we are going to find out the opposite way. Always we are going to work out the opposite working. Total arrangements with 3 E's together. Okay, with 3 E's together, because what's the question requirement? What the examiner is asking for? Total arrangements with 3 E's together. The examiner is asking that it should be 3 E's not all together. So I'm going to find out that total arrangements, the opposite of them, total arrangements with 3 E's together. So it will be similar. If you got the first part, you will get it. 3 E's together will mean that this 3 E's are coming together. Okay, one box, and then you can write CIV and D and D. Okay, so these will all be in 5 different boxes. Okay, because now there is no restriction of D as well. Okay, so D will be written as separate as well. So CIV and DD. Okay, so again, now how many boxes are there, students? If you start counting, there will be 6 boxes now. 1 2 3 4 5 6. So which means this time it will be 6 factorial. Okay, 6 factorial for the 6 boxes, because each of the box can change their place. This is made by your instructor, this is made by me, but any student can start with C first, then D, and then 3 E's. Okay, so a lot of possible arrangements are there. Then I, then again D, and then V. This is one example I'm giving. Okay, this is example I'm giving. This is student number 1 made. Okay, student number 2 can make with D first, then C. Okay, and then it goes on I, and a lot of ways are possible. Okay, students, so that is why 6 factorial for the 6 different arrangements that are possible, and then you multiply with 3 factorial. The reason everyone knows 3 factorial, the reason is because e's can change their place. Okay, the e's can change their place inside the bracket. Okay, what I mean by inside the box, they can change their place. So inside the box I'm going to explain as well. Let's say this is E1, E2, E3, so you can understand they can change. This is 1, this is I made it. Okay, some other students can make E2, E3 and E1. Okay, then the other person can make E3, E1, E2. So a lot of them say a lot of more are possible. Okay, I'm just giving example, a lot of more are possible. That is why 3 factorial for them, no 2 factorial multiplied, because D's are already separate. Okay, and then you divide this by the same, that is with, because it is repetition, so you divide 3 factorial for the 3 E's and 2 factorial for the 2 D's. So you are going to divide them, which indicates that your final stance will be that, sir, this 3 factorial with 3 factorial will cancel out, and we are left with, sir, 6 factorial divided by only 2 factorial. That is going to be my answer, sir. So here we go, students. Okay, so 6 factorial divided by 2 factorial, this is going to be our answer, and here we go, it's going to come as 360 ways. Okay, so this is total arrangements that are possible with 3 E's together. And now you will go for the final answer, final working. This is 2 marks as well, and the last mark will be the answer mark, that is the total arrangements, all working, all everything I'm showing, students. So total arrangements with 3 E's not all together, with 3 E's not all together. Okay, so I'm making it bold as well. With 3 E's not all together, it will be simple, sir. It will be 3360 total arrangements minus the E's together. So your answer is going to come 3000 ways as the final answer, which will give you all 4 marks. Okay, so I've explained you how do you get all 4 marks in this type of question as well. First mark for total arrangements without any restrictions, 2 marks for finding out 360 ways with 3 E's together, and 1 mark for the final answer. So this is the first question that we have done on permutations, combination of a word, which is basically talking about arrangements with restrictions, as well as how do you deal with repetition. Understand, we'll do more questions and students will get better. Any questions can be asked in the comment section, students. Thanks.